Hi guys, my name's Lindsay, and today I want to take a few minutes to talk about finding an unknown angle using trigonometric ratios. And if you're interested in finding an unknown side, we do have a video for that, so feel free to take a look at it. But in this one, we're going to focus on finding an unknown angle. But before we do that, let's talk a little bit about what we're going to use to do that. So we're going to use trig ratios. We're going to use sine, cosine, written short form as cos, and tangent, written as tan up there. But in order to use those ratios, we actually have to talk about one other concept first, and that is these three words right here: hypotenuse, opposite, and adjacent. So I've drawn two right triangles. This can only be used in right triangles, and the reason is because of the hypotenuse. So in both of these triangles, I'm going to label the hypotenuse. Hopefully you know this already, but if you don't, that's why we're doing this. The hypotenuse is right across from this 90-degree angle, or this right angle right here. So right across from that, that is the hypotenuse. I'm going to write hype. And same down here, same situation. Here's the right angle, right across from that, that is the hypotenuse. So this is only going to work if we have right triangles, because you need the hypotenuse, which is only across from the right angle. So the other two words I have here are opposite and adjacent. Now, you can see this little squiggly guy here that I've drawn in both of those triangles. That is called a theta. It's just an unknown angle. It's an angle that we don't know. We tend to use letters like X or Y or A or B for unknown sides, and theta for unknown angles. So the opposite side in these triangles is always opposite the theta. So right now I've got my little theta up here, which means this is the opposite side. And the reason I have two triangles drawn here is because this one's a different situation. Instead of my theta being up here, it's down here, which means now this side is my opposite side. And the leftover side on both of these is the adjacent side. So let me just write that there. And labeling these properly is the first step in doing these questions. That's where we've got to start always. So we've done that. So now let's talk about our trig ratios. If you haven't seen this before, I'm going to talk you through it. SOHCAHTOA. So these, it's actually just a quick memory aid to help us remember all three of those trig ratios. So first we have SO, S-O-H. The S in SO stands for sine. And I'm going to put the little theta, the little unknown angle sign beside that. And then the O stands for opposite. And we're going to put that first letter on the top of a fraction. And we're going to put the H, hypotenuse, on the bottom. So now we have an equation that we can use to find either an unknown side or an unknown angle. There's three pieces of information here. There's an angle, and there's a side and a side. So two sides and an angle. As long as we have two of those, we can find a third one. So today we're going to focus on finding the angle. In our other video, though, you could look at focusing on finding a side. Let's talk about the other two. So we've got CAH as our second one. The C, as you can probably imagine, stands for cos of our theta. The A is adjacent. First one always goes on the top. Second one always goes on the bottom. So now we have a second equation we could use. Again, as long as we have two of those pieces of information, we could find the third one. And our last guy, TOA, T is tan. We'll put our little theta guy in there. And opposite over adjacent. So, three equations that we could use to find something that we don't know, whether it be an unknown side or an unknown angle. So let me make myself some room here, and we'll look at a couple examples. Okay, so now I've made myself some room, and I actually just wrote a couple examples up here that we'll do together. And I kind of like having SOHCAHTOA written, so I'm going to write that again, just so we can refer back to it. Okay, so let's start with our first example. Now, if you wanted a question written here, I guess the question would say find theta. And again, theta is an angle. So in this question, we're going to find that guy right there. And if you've seen our other video about finding a side, you'll know that the first thing that we do is label these three sides before we do anything else. So let's do that. Here's the right angle. So right across from the right angle, that's hypotenuse all the time, no matter what. Now the angle I'm trying to find is the angle that's going to be in my calculation, which means directly opposite. That would be the opposite side. And then my leftover guy is the adjacent. A, D, J. Okay, so I have got my opposite and my adjacent side. I don't have my hypotenuse. I'm not looking for my hypotenuse, so let's not worry about him in the calculation. So of these three, sine, cos, and tan, which one contains the opposite and the adjacent? Well, it looks like this guy does. Tan. Opposite and adjacent, so I'm using tan. So the tan of my angle equals opposite over adjacent. So let's fill that in. So tan, and always after the word sine, cos, or tan, we put our angle there. So I don't know what the angle is. I'm going to leave that as a theta. My opposite is 17, and my adjacent is 12. So at that point, we're going to have to use our calculator. I'm going to figure out what 17 divided by 12 is. So the tan of our theta is, let's figure that out. So 17 divided by 12, I'm getting 1.416 repeating. 416. And I'm going to put a line over top of the 6 to show that that repeats forever. It's important not to round that number because that could change my final answer. And here's the trick to this question is I'm trying to find that angle. That's not the angle. That is the tan value for that angle. In order to find the angle, I'm going to have to press either inverse tan or second function tan, depending on your calculator. For my calculator, I'm going to use my second function button. So I am going to, and if your calculator, you might have a calculator that looks like this, tan with a -1. The inverse tan, you've got to press that on your calculator. So I have 1.416 repeating on my calculator right now. I'm going to press second function tan equals, that's my answer. So theta equals 54.8 if I round. So anytime we are trying to find an angle, we've got to press that inverse or that second function button on our calculator. And I put degrees here. The reason I put degrees there is this angle is in degrees because my calculator is in degree mode. If I look at my calculator, I have a little DEG written at the top. You might have a little D. If you have rad, R-A-D, or a little R, or a little G for gradients, you're in the wrong mode, and you're actually going to get a different answer than I will here. And if you tried that on your own and you got a different answer, make sure you're in degree mode to do that. So hopefully that's what you got. And let's move on to just a quick second example. So here we've got another one. If I want to get this one done, what I want to do first is label it. So here's my right angle directly across from it, hypotenuse. And then here is the angle I'm using. So this guy is the opposite. And my leftover guy is the adjacent. So this time I am using my hypotenuse and my adjacent, not worrying about the opposite. So different situation, I'm not going to use tan this time. Hypotenuse and adjacent. It looks like this time I'm going to use cos because it uses adjacent and hypotenuse. So let's do that. Let's write for us here. The cos of the angle I'm trying to find would be adjacent over hypotenuse. Adjacent, 16. Hypotenuse, 31. So in my calculator, first I'll do 16 divided by 31, get my answer. So I'm getting that the cos of theta is 0.516129. It goes on for a really long time. I'm going to write 0.516. And I'm actually just going to put dot, dot, dot here. to imply that I didn't round it to that. I'm leaving the whole number on my calculator. It's important not to round at this point. So now I'm going to find the inverse cos, or press second function, depending on your calculator, to find that angle. And if I do that, I didn't clear my calculator. That number is still on here. I'm going to press second function cos equals, and as long as I'm in degree mode, I should get 58.9. Hopefully that's what you got as well. Degrees, because I'm in degree mode. So why don't I take a minute, clear some space here, and let's take a look at an application question. All right, guys, I'm back, this time with an application question. So let's read this through together, and then we'll talk about how we're going to solve it. So the walls supporting the low and high end, so there's the high end, and the low end of the cathedral ceiling have heights as shown. You can see them written there. Determine the angle of the rafter with the horizontal. So this angled piece right here is the rafter, and the horizontal would be where the rafter ends if you drew a horizontal line. That's the angle we're looking for is in there. So let's just quickly pull that triangle out. Never a bad idea. Diagrams are always a good thing. They help you kind of clearly see what you need to do, help other people who are looking at your work understand it clearer. Okay, so we are looking for this angle. And I put a right angle in there because I'm going to assume that this horizontal and this vertical wall are going to make a right angle. If this wall is not perpendicular to this horizontal, you built it wrong. So hopefully that didn't happen, and that creates a right angle. So let's put the information on our triangle that we know already. If this bottom section is 5.3 meters, this horizontal would be 5.3 meters as well, assuming that it was built square, and we're going to assume that. So this is 5.3 meters. And then we've got this side right here, so this guy, and that is from here to here. I don't have the measurement there, but hopefully it makes sense that if I take the high side and I subtract the low side, so 3.8 subtract 2.3, so that gives us 1.5. That would be that side right there. So now we have two of our sides. The units are here in meters. What's important about these calculations is just that the units are the same. As long as they're the same, then we can use what we've been using. So let's write SOHCAHTOA here. It's always nice to have it in front of us. Why don't you take a minute and see if you can solve this situation. Find that angle given those two sides. Okay, so I'm hoping you tried that one on your own. Again, you don't get good at math by watching me do math. You get good at it by trying it. So I'm hoping you gave that a shot. So let's figure it out together. Let's first label those sides. So right across from the right angle, hypotenuse always. Now I've got the angle I'm trying to find. So that's the angle that's going to be in my calculation, which means right across from it, right opposite of it, is my opposite side. And my leftover is adjacent. I'm not going to worry about hypotenuse. I'm going to use adjacent and opposite because I have it. So of these three ratios, adjacent and opposite, looks like they show up in tan. So I'm going to use my tan ratio. So let's write that down. So the tan of an angle, TOA, is opposite over adjacent. So let's plug our information in. Theta, I don't know it yet, and that's okay. Tan theta is opposite over adjacent, so opposite, 1.5. Adjacent, 5.3. And now I am going to do that in my calculator. So I'm going to type in there 1.5 divided by 5.3. And if you remember from our last example, I'm not going to round this number. So I'm getting 0.283, and I'm going to put a dot, dot, dot here to imply that I didn't round it. I kept that whole thing on my screen, and then I'm going to press second function or inverse tan to get my final answer. Every time that we're using a trig ratio to find an angle, we've got to use that inverse button or that second function button. I've got that value on my calculator, so I can go ahead and press second function tan. and I get 15.8 degrees because I'm in degree mode. So it looks like the angle that the rafter makes with the horizontal, that guy right there, is 15.8 degrees. So I'm hoping that that video helped you not only understand how to find an unknown angle using trig ratios, but also to understand a situation where you might actually use that.